In this video, we're going to look at topic 27, example 3, use the power of a power property to solve equations with rational exponents. They give us two examples, and in example A, we're asked what is the solution of 27 to the x minus 4 power equals 3 to the 2x minus 6 power. So we've done problems similar to this where we've been looking to set exponents equal to one another. The difference, however, here is that our bases are not the same. So what we need to do is we need to have these two numbers be exactly the same. We need identical bases before we could set the exponents equal to one another. So I'm going to look for is bases of 3. Right? Usually you want to start with the smaller number and see if the larger number can be written as the base of the smaller number. You'll see what that means in a second. So we have something like 3 to the 0 power would be 1. 3 to the first power is 3. 3 squared is equal to 9. 3 cubed is 27. So this is what we're looking for here. All right, we want to find a way to rewrite 27. And what you can do is rewrite 27 as 3 cubed. All right, they have the same value. We're just going to write them in a different form. And then the right side will stay the same. Now, here I have a powers to power property. So I'm having 3 to the third raised to the x minus 4 power. These terms get multiplied. So this left side would become 3 to the 3x minus 12 power. And that, again, the right side would stay the same. We're not doing anything with that yet. Now I have identical bases, and I can set the exponents equal to one another. So I can take 3x minus 12 and set that equal to 2x minus 6. So we'll do that over here. 3x minus 12 is equal to 2x minus 6. And now I can just solve for x. I have an equation with one variable. Subtract 2x from each side. So it leaves me with x minus 12 equals negative 6. Add 12, and x would be equal to a positive 6. So again, to do this, you're looking to set the equation, create an equation where the bases are identical. Right? So we had 27 and 3. We wanted to rewrite the 27 as something with a base of 3 to some power. Once you have that, then when you're raising powers to powers here, this 3 to the x minus 4, those are going to get multiplied, and that's where you got the 3x minus 12 from. So in problem B, you're doing the same thing. You just have to be a little more careful because now we're dealing with fractions. So let me rewrite this first. We have 1 over 125 to the negative x over 2 power equals 1 over 25 to the negative x over 3 minus 2 power. All right, so one of the first things I would look at is trying to find the bases and see if they can be both written as 25. So if I do 25 squared, that is not going to be equal to 125. So right away that tells me that I cannot use bases of 25. So I want to look at numbers that I know give me 25 or 125. Well, 5 to the first is 5. 5 squared is 25, so that's one of the numbers I want to work with. 5 cubed is 125, so that's the other number I would want to work with here. So in the previous part, or example, part A, we only had to change one of the bases because it matched up with the right side in this case. In part B, you have to change both bases. Now I'm going to show this keeping them as fractions. It's also possible to use negative exponents to get the same bases here, but I'm going to keep them as fractions. The reason I can do that is the 1 in the numerator really makes my life a lot easier because 1 raised to any power, right, is just 1. So if I just keep raising 1 to a power, I'm still going to get 1. So I'll actually have to use this one and this one. Although nothing will be done with it, that's kind of what's happening. So the 1 over 125, we're going to rewrite that to the third power. So again, this here, 5 to the third and 1 to the third Kind of gives me, oh, that's not supposed to be 125. That's supposed to be a 5 there. So these two to the third power gives me those two numbers I was looking for. And then on the right side, I'm going to use 1 over 5 again, but this time it's going to be raised to the second power. Okay, and the reason I can do that is because 1 squared messed up here. So these go here. This here, I don't know why I wrote 3's here. These are supposed to be 1's, so I'm going to fix that. Sorry about that. All right, so going back to the actual changes, let's make some sense of this because probably got a little confusing for a moment because of my mistakes here. So 1 over 125, if I raise 1 to the third power, so I'm looking here, if I raise 1 to the third power, I still get 1, and 5 to the third power is 125. So I'm rewriting this as a base of 1/5. On the left side, 1 over 25 can be rewritten as 1 over 5 squared, because 5 squared is 25, 1 squared is 1. So now I have these two written with the same base, so I can continue my problem. Remember that powers raised to powers are going to be multiplied. So we're going to multiply this 3 times the negative x over 2. So we get 1/5 to the negative 3x over 2 power, and that is going to be equal to, this 2 must be distributed, so we'd have 1/5 to the negative 2x over 3 minus 4. All right, so you want to make sure that you distribute this 2 up here. So this 2 got distributed, and that's where we got these numbers. Okay. Now we have the same base, so we can take our exponents and we can set them equal to one another. So we'd have negative 3x over 2 is equal to negative 2x over 3 minus 4. Anytime I have fractions, what I would look to do is I would look to multiply the entire equation by the common denominator. So this 6 is a common denominator, and that'll help me clear the fractions. So 6 times negative 3x would be negative 18x over 2, negative 12x over 3 minus 24. So I now have negative 9x equals negative 4x minus 24, and I no longer have fractions I have to worry about. So I can solve this equation by moving the 4x. I'm getting ahead of myself here. So I'm going to add 4x to both sides. So at negative 5x equals negative 24. Divide both sides by negative 5. And x would be equal to 24 over 5. Or if you wanted to write this as 4.8, that would also be fine. So either one of these is acceptable. So the idea behind these problems is you have to find common bases before you can set the exponents equal to one another. And to do that, you would do kind of what I listed on the left here or on the left here, where you're just looking to rewrite the terms. And then A, 27, we wanted to rewrite as 3 to the third power. And then B, we wanted to rewrite our fractions to be the same base. Not the easiest problems, but with some practice, you will get the hang of them pretty well.